We have to write these in standard form, which just means we have to write it out, right? Oh, I thought I unfroze it. Sorry about that. There we go. So this first one, bless you. This is really being divided by 10 to the 12th, which is a giant number, which means we need to move this 11 places. Like that's the shortcut. Well, 12 places, we're going to have 11 zeros in front. We have to move it 12 places to the left, which means there's going to be 11 zeros. So let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 8, 2, 3. Good? Questions? Did I do it right, Parth? Yeah? Okay. Oh, that reminds me, yesterday when I was going over your quiz with you, I made a mistake. The really ugly exponent problem, the answer is just 8, not 9 squared times 8. I don't know how I did that, but after you guys left, I'm like, wait a minute, I did something stupid. And I threw my paper away, so I can't even find my mistake, but it's just 8. So if you're trying to review that later and you're like, wait a minute, I'm not getting the right answer, it's just 8. Okay, next one. We have to multiply this by 1,000,000. 10 to the 6 is the million, I think. 1,000,000. Is it, Anna?
1,000,000.
Because it would be 1 followed by 6 zeros. That's 1,000,000, right? Because it would be 1, 2, 3, 1, 2, 3, 1. Yeah, that's 1,000,000. So let's see. So I have to move it 6 places to the right. There's already 3, so I need 3 more. Good? Questions? No? Mikey, we're good? Okay, now this one. We have to write these in scientific notation. This one's not in scientific notation because it needs to be 5.108. Now the trick is we have to change this exponent correctly. So what we actually did to make this number into that number, didn't we divide by 10? Isn't that what happened? So to keep it equal, don't we have to multiply this side by 10? Because they're like, it's just one number. So we're really dividing and multiplying the same number by 10. And that would make multiplying by 1, right? So if I multiply this by 10, wouldn't that be like this? Is that right? Yeah, you sure?
Yes.
Okay. All right.
So we have to do both sides?
Well, it's one whole number. It's just a number. Like the way you're changing this by moving a decimal, what you're really doing is you're dividing it by 10. But if you write 5.108 times 10 to the negative 12th, that won't be equal to...
I wrote it to the negative 13.
Yeah, no. That's why you can't just go with the rule if I'm moving left. I mean, now I understand what your question was. I thought you were talking about this kind. Yeah. Yep. So like this one, it needs to be 2.5. But it looks like we're moving 3 places, correct? So we're really multiplying this by 10 to the third. Or is that 10 to the negative third? Are you sure? I heard your hand go up, Dylan.
I think you would be subtracting, well, you would be dividing from 10.
I'm just talking about this part. Changing this into... How do I change that into that? That's multiplying, because this is a bigger number. That's 10 to the third. Right? Now, in order to keep this number the same, since I multiplied by 10 to the third, I also need to divide by 10 to the third. Well, it's the same as multiplying by 10 to the negative third, right? Because these would make 1. So I need to multiply that one. I think that's 10. What do you think, Parth? You think that's right? How can we use this to check and see if we're right? How can we do that? Tell us, Tristan. I could plug this number in and plug my answer in and see if they're the same? Okay. So 0.025, 0025, right? times 10 to the, wait, how do I do to the 7th power? Little caret. 25,000. Okay. 2.5, 2.5 times 10 to the 4th, right? Same. These are tricky. These are tricky. You have to know what you're doing. You'll confuse yourself if you don't really know what you're doing. Okay. We have to do this, and we have to write them in scientific notation. They're not the same base, do you see? Oh, it's multiplying though, so it doesn't matter. See, look, 2 times 3 times 4 times 5. Could I do this the same as 2 times 4 times 3 times 5? Would that be the same? Yeah, you can change the order when you're multiplying, and these are all multiplication, do you see? So I could do 3.21 times 4.998 times 10 to the 7th times 10 to the 3rd. That's going to be times 10 to the 10th over there. Yes, Tristan, or no? Do you have a question? No? Okay. And then I'm going to use my handy dandy calculator. 3.21 times 4.998. 16.04358. That's a lot of digits. Okay. We should probably round that, but we're not for now. That's not scientific notation. This is. To make 16 into 1, I divide, right? So to keep it equal, I have to add, I have to multiply this by 10, so that's going to be, you see? Because I had to make 16 into 1, that's division by 10, or it's 10 to the negative 1 power. And so to keep this the same, I have to multiply that by 10 to the 1. That's how you move these decimals around. It's actually math. It's not just moving decimals to the left and changing signs. It's like math, which is weird because it's math class. It's weird. It's weird, right? That's weird. Yeah, I know. It's weird. That's right. Huh. What do you call a cow that doesn't have back legs? No. That's a cow with no legs. It's an udder drag. Har, har, har. I'll be here all week. Okay, Carlos. Carlos, this one's different because it's addition. And the order of operations gets a little funky right here. So what we can do a couple things. We could either write this whole number out and write this entire number out and then add them. Or we could be smarter, make them the same base. So I could make this a base of 10 to the 3rd, or this one a 10 to the 7th. It doesn't matter. You get the same answer either way. Let's make this one 10 to the 3rd. Okay? So to make 10 to the 7th equal to 10 to the 3rd, do you have to multiply by 10 to the negative 4? Is that right?
Yeah. Oh, yeah.
So really, I need to multiply this whole thing times 10 to the negative 4.
Yep.
Like, well, so I'm multiplying this one times 10 to the negative 4, which means I'm multiplying that one by 10 to the 4. So they'll be equal. Because these two things would cancel, right? It's just one number. It's like this. It's like this. Say I had 5 times 3, right? That's 15, I think. Is that 15? Yeah. Azalea, that's 15, right? Okay. So if I multiplied this number right here by 2, what would I have to do? Because that would no longer be 15, right? That would be 30, right? So in order to keep it 15, I would have to divide that number right there by 2. Right? Yeah. You know, with an equation, you have to do the same thing to both sides of the equation, right? Well, if it's not an equation, if it's just an expression, you have to do opposite things to keep them the same. And that's going to be a big idea that we're going to start seeing pretty soon when we end up having to do this thing that's really tricky called solve by completing the square. It's going to hurt your feelings. And it's this concept right here. that's going to make it difficult. We're not changing this number because we're multiplying and dividing the same number by opposite things. Where were you?
Band.
Band. Okay. So this number would be 3, 2, 1. Let's see, that's 0, 0. Would that be right? Because I have to move the decimal 4 places that way. Is that true?
Yeah.
Times 10 to the third plus 4.998 times 10 to the third. Is that good? You sure? Abraham, we're good with this or not good with this? Talk to me, Goose. Not?
Not good.
Why? What's your question?
I have no idea what you've done.
I've changed this to a base 10 to the third so that I can add these two numbers together. That's all.
Okay. Alright.
Is that it?
Yes, sir.
Well, why do you, I sort of understood when we were doing the 15th, well, why do you do one side divided and one side multiplied?
To keep the number the same?
So we always do that for each problem?
Well, wait. There's no always. It's not like it's an always step. We're keeping this. We're changing the way this number is written, but it's the same number. But we want it to be the same base because then then it will be like terms. These are like terms. This is 32,000 10 to the thirds, and this is 4.98998 10 to the thirds. We're changing this number so that it has a 10 to the third, so we can add them. So this would be 3210.4.998. Yeah? Yeah? Okay, so we need this is stupid. That's stupid. Times 10 to the, let's see, we had to go 1, 2, 3, 4. So we really divided this by 10 to the fourth. So we have to multiply that by 10 to the fourth, so. Yeah? Brandon,
Yep.
can't believe you didn't do your homework.
I know.
Man, that's a sad story. This one we have to be careful of the order of operations, yes? Oh, what's up, Parth?
The fourth one, you can do it the other way around too.
Yes, you could definitely do it the other way. You get the same answer. Or you could actually figure out what this is like we did with number 1 and 2. And figure out this one is the same way and add them together and then convert back into, scientific notation and you'd be good. Okay. Ani, do you have a question?
Oh, no, I made it out.
Oh, okay. All right. We have to multiply these together first before we can cube. So let's do that. Or we could cube everything, but I think it'd be easier. Hey, didn't we just do this? Right here? And this was our answer, yes? Okay, so I have 1.604358 times 10 to the 11th cubed. Uh-oh.
Would that mean that the number would also
Yeah.
be
So does this number right here get cubed?
Yes.
And this gets cubed?
Yes.
Like that?
Yes.
Because I would distribute that, I'd have to because it's like this right here. Here's what it really is, right? It's a times b cubed. That would be a cubed times b cubed. Yes?
So wouldn't you have to, or can you just leave it like that?
So here's what we're going to do. Because this is so many digits, we're going to round this to 1.6
I mean, do
times 10 to the 33rd. Okay? Just for the... we'll do it this way because Parth doesn't like that idea. Was that our number? Well, divided by 10. Is that our number right there? It was in my calculator from a second ago. Is that our number? Yeah? So I need to cube that. So, 4.129. I'm going to stop right there. Oh no, 6. We'll stop right there. So that's not so bad because it's just the 1 decimal place, which means we're already okay for scientific notation, right? Times 10 to the 33rd. Anybody get something different? Maybe I messed it up. What's up, Parth?
So in the test, will you specify if you need it on the 10 decimal point or do you need it?
You know, usually for Cambridge we do three. It's called three significant figures. And so, yeah, we usually will round to 3 places, but yeah. But it'll tell you. Do you have questions, Anna? Are you sure, Anna?
I remember we did the 3 significant figures, but I never done.
Oh, okay. It's not too bad. I'll show you when we get to that. Yes, sir.
For number 3, if we did it like number 4, where you switch the 3.21 to 32,100, would you multiply like the 10 to the 3rd power? Would you multiply them together?
Yeah, because it's multiplying.
And then you would get like 10 to the 6th.
Yep. And then you have to reconvert it back, and eventually you get 11. Yeah, but since you're multiplying, you don't really need to convert anything because they're like. Okay, here's the question. I think. Let's say we had 1.2 times 10 to the 5th plus 1.2 times 10 to the 4th. Oh, there we go. Here's my question for you. Why do you have to want these to be the same before you can add? Tristan, why are you turned around facing the back wall? Is it because Pierre's here? Why is Pierre sitting in that chair? To distract you? I don't think that's a very good combination. Do you? That's like jalapenos and peanut butter. That doesn't sound good. Huh. It's like cat food and liver. Oh, you can see better from there. Oh, I see. So why do we have to convert one of these to be the same as the other before we can add? Yes, sir.
Because there's like the denominator.
What do you mean?
They have to be the same so you can add or subtract and all that.
Well, why do you have to? Okay, so you're saying like you have to have the same denominator to add? Why is that?
Because then you can,
Abraham, why do we have to have these things the same before we can add them? Oh boy. Yes, sir. Why?
Because of the order of operations. First you have to do the multiplication. before you can add.
So we can see this really well. We can see that the order of operations is causing us problems because you have to multiply before you can add, right? Okay, but let's see. Would that be, let's see. So why can I add these now? Because didn't I add before I did the multiplication? Did I just violate the order of operations? Yes, sir.
Isn't it because they're like terms?
So you're right, because they're like terms. And these are not like terms. 1/3 and 1/2 are different terms. You have to get them to be the same term before you can add them. That's right. And it actually goes back to factoring and all kinds of stuff. But yeah, which we'll learn soon, like factoring stuff like this. Okay. All right, ladies and gentlemen, especially Brandon, especially you, Brandon. Here's what we're going to do today. Did we do that one yesterday?
No.
We didn't? Or we did?